All right, we're going to explore parallel line equations today. You'll remember, we did this a while back, but I have a feeling it's kind of escaped some of you, which isn't a big deal. It happens. You haven't used this in a while. But you do have some questions on the homework about it tonight, so it's worth going over. Now, first of all, we want equations that are in slope-intercept form. Now, if you remember, slope-intercept form is y equals mx plus b. M is your slope, and b is your y-intercept. That's going to come in handy, so remember that. Can I squeeze that in? Heck yes, I can. Awesome. You want to be familiar with this form? You want to be familiar with these terms. It's going to come in handy. Now, parallel lines. Their slopes are always the same. So parallel lines have the same slope. That's really important to know for this. Parallel lines, same slope. So when you have equations, you can tell if they give you parallel lines by whether they have the same slope or not. If they have the same slope, different y-intercept. Okay, squeeze that in. Now I'll just put y-inter. So I'll give you an example, right? So an example of two parallel line equations. You get y equals, we'll say, negative 4x minus 1. Now, the slope in this case is going to be negative 4 right here. And I was hoping that would be a better highlighter, and that didn't work out so well. Oh, that was awful. Still learning this program, so bear with me. All right, so negative 4. Cool. So for my next equation here, I can write anything for my y-intercept, but I have to keep the same slope. So the slope is negative 4. Got to keep my x, and now I can come up with any y-intercept I want, and it's going to give me a parallel line. I could go with positive 1. I could go with negative 4x plus 1,000,000. Really doesn't matter. Whatever that y-intercept is, as long as the slope is the same, you're going to get parallel lines. Now, that might seem nice and easy, and for the most part it is once you get the hang of it. The trick is when you have to come up with an equation that's parallel but goes through a specific point, which is what you're doing on the homework tonight. So let's do an example. Say I had, here's my equation. We'll go with y equals 5x minus 10. Okay, we want a parallel line that passes through, we'll just make up a point here, negative 2, positive 3. All right, this gets a little nasty, but let's think back to what we know here. We know the slope. The slope is really important. Let's go with that slope that we know. We're going to go with that slope right here, which is 5. So we know in this next equation we have to have a slope of 5. Now, we have to come up with an equation that's going to pass through this point, though. This is where it gets tricky. Now, let's think. We have a point, we have a slope. A point and a slope. Where have I heard this before? Point, slope, point, slope. Hey, wait a second. Something ringing the bell? Hopefully it does. We are looking for point slope form. Remember that? Yeah, we did that a few weeks back. It was on one of your tests or quizzes. So point slope form. Point slope form. Now for point slope form, and come on stylus, awesome. The equation is y minus y1 equals m times x minus x1. All right? Now, with point slope form, we need a slope. Wait a second, we've got a slope. If you go back up here, boom, that slope of 5, I can plug that in right here. Now, the y is going to stay, and this x is going to stay. But now I'm going to plug in my coordinates. Now, for my x value, I've got negative 2 right here. So I'm going to slide that in right here where the x1 is. And for y, I've got 3. So I'm going to put that right where y1 is. And this is half the battle. Once you get this far, you are in pretty good shape. Now, all I have to do is I have to simplify this bad boy, which I can do. I'm going to use the distributive property. Well, first of all, I'm going to make this addition because two negatives, awesome. Then I'm going to use the distributive property. I get y minus 3 equals 5x, and then 5 times 2 gives me 10. Cool, so I'm almost done. I've only got one more step. I'm going to have to go to the next slide. I don't know how to shrink this stuff. Maybe I'll learn at some point, but I'm going to have to go over and see if I can remember this. Which is, hey, what do you know? That was nifty. Y minus 3 equals 5x plus 10. Awesome. Remembered it. Now, in order to get this equation, I want slope-intercept form again. Slope-intercept form means I got to get that y alone. To get that y alone, I'm going to use inverse operations, add 3 to each side, and now I have that equation. Awesome. I am done. I now have a line that is parallel to my original equation, which I'm going to go back. 5x minus 10. Hey, that worked out pretty well, huh? So as you can see, two different equations, same slope. We love that same slope here. So we got the same slope. 5, perfect. Different y-intercepts right here. Awesome. So that's what you basically want to do. You want to take that slope, you want to take your point, pop them into that point-slope form equation, and then you got yourself to the point where you can get that equation that you need. Let's try one more. What the heck, right? All right. So I'm going to go with, let's see, y equals, I'm going to just make this up, negative 3x plus 7. Okay? I want a line that is parallel and goes through, what do you think? What should I come up with here? No, I'll make it interesting. 11, 2. Wow. All right, so I want to make sure it goes through point 11, 2. All right, so first of all, I need my slope. What's my slope? Negative 3 is my slope. Great. So I'm going to write my point slope form equation, y minus y1 equals m, and then x minus x1. Great. Plug in what I know. I know my slope. I know the coordinates of my point, which I have right here. So I'm going to do x. That x stays the same. I'm going to plug in the x value of 11. Now I'm going to plug in my y value, y minus 2. Great. And now, this is almost done for me at this point. Now it's just a matter of just doing some simplifying. I'm going to distribute negative 3x plus 33. Looks like we're going to get a big, nasty number here. Y minus 2. Now I want to get that y alone. Add 2 to each side. Add 2 to each side. And I get y equals negative 3x plus 35. Quite a different y-intercept, as you see. But our slopes are the same. We have, I'm going to use a different color here, negative 3, negative 3. Same slope, so they must be parallel. Different y-intercepts, positive 7, positive 35. Now, if you put these on a graph, which it might be a bit hard because you have such a wide variation on the y's here, but if you put them on a graph, you'll get two distinct parallel lines. And that is what we are doing here. Cool.